Hello and welcome to my talk, Like Bees to a Honeypot, a journey through honeypot deployments. So I have prepared a little bit of content for you. Basically, we'll start with some technicalities and then do some fun stuff in the end, all rounded up by a conclusion. So maybe we should start by giving you some context. So about me. What I do for work is I work for VMRay as a labs infrastructure tooling and automation developer. So basically I'm providing most of the tools and automation for the labs team so that they can work efficiently. What I do for fun is what you are about to see today, as well as CTFs and photography. So basically this is what I do for fun. So please don't yell at my employer, yell at me instead. So maybe let's preface this a little bit more, because it's a tale of things I've tried and am trying. So it's an ongoing process that never really is done. So I am no expert in any kind of way. It's just a tale of things I've tried and am trying. So if you see something that you think I can do better, please go ahead and tell me. I would be very interested to learn from you as well. So, as this is a public talk and honeypots are kind of a one-shot customized thing, I'm trying to show you what you can do, but not how I did it in detail, just to preserve my tweaks and customizations and try to at least have my honeypots undetectable or hard to detect as long as possible. So this is also one of the main reasons you find comparatively less talks about this topic, because people want to preserve their knowledge and not burn their customizations by telling the world how they can detect the honeypots. Again, if you're interested in details, find me afterwards, find me on Twitter, or just message me or mail me if you want to. So maybe we should start with the intro of what a honeypot is. So a honeypot basically is a system intended to mimic likely targets of a cyber attack. What does that mean? So honeypots basically look like vulnerable systems, and they can either emulate a server, so something like SSH, MongoDB, an IoT device, or even a mail server. Or they can emulate a client, like a browser, for finding drive-by downloads or malicious JavaScripts. The majority of honeypots I know of are server honeypots, so this is what you tend to find outside. You can further group honeypots into 3 distinctive groups, which are low, medium, and high interaction honeypots. Low interaction honeypots are quite easy to define. So these are basic scripts that present a protocol conform login and try to grab the credentials. So if we take SSH as an example, this could even be a simple script that does nothing else than presenting an SSH login and then logging the credentials, so the username and the password that were entered. Medium interaction honeypots are a bit squishy to define. These are still scripts, but they emulate a full system without being one. As an example, there is Cowrie, which is a medium interaction SSH honeypot. So Cowrie emulates common commands and even part of a file system without running a full Linux kernel somewhere. This is what high interaction honeypots do. So, for example, Docpot is running a full Linux image as a Docker image that is then open to the world as a man-in-the-middle proxied connection that you can connect to. So every command and every interaction with a real Linux system is logged, and the system is discarded afterwards as soon as you close the connection. So if we think of the 3 main groups as kind of an inverse pyramid, you can organize them like this. And what's interesting is the detail and the insight increase if you go from low to high interaction honeypots. So you start with just grabbing passwords and usernames, and you end up with seeing exactly every command and interaction with the system. But detail and insight aren't the only things that grow. The error potential and the attack surface are also things that increase, and with that, I mean, the more complex the system is, the more chances for mistakes there are, especially in regards of deploying and configuring the honeypot right. And last but not least, the hardware demand and the complexity increase as well, as high interaction honeypots tend to be quite computationally intensive tasks, as well as being quite the complex systems. So up until this point, you might ask, why should I do that then? So basically, there are three main scenarios that might be of interest. So you can use honeypots to find attackers in your network. So basically use them as kind of a trap, as in you deploy them into your internal network, you don't tell anyone that you did, and then you monitor for incoming connections or port scans. Basically, you can tell that as no one knows this is a system that exists, no one should be connecting to it anyway. So you can think of every connection as being potentially malicious and something you should investigate as soon as possible. The second big use case of honeypots is getting general grasp of attacks, as in what is happening outside. So looking at the new malware campaigns or the newest credential stuffing attacks, or even the new exploits that are out there, especially over the last weeks, all major vendors got hit with more or less bad bad software flaws that they had to patch. And you can build honeypots for this and have a look at what people try to do with them. And last but not least, you can check for open directories and malware payloads, because usually when malware is distributed, it has to be distributed from somewhere. And this can be interesting as in finding new payloads or finding variations of existing ones, as well as even finding campaigns, ideally. So what this talk focuses on is options 2 and 3, so getting general grasp of attacks and finding open DIRs. Deploying honeypots in your own network has some drawbacks and considerations that should be seen as different than at least getting open DIRs and getting a general grasp of attacks. So maybe it's time to tell you how I got into this, because many years ago I set up an FTP server with quite weak credentials by accident, and it ended up hosting things that I definitely did not put there. So I then started noticing that basically every public-facing service was getting brute-forced more or less. And years later, I revisited this topic by using a Raspberry Pi, or starting with a Raspberry Pi, installing Cowrie, the medium interaction SSH honeypot on it, and just having it running in my home network. And it ended up being a multi-install system that is spanning the globe on different VPSs. And I then started seeing that crawling logs of every single honeypot by hand is a tedious task. So I wanted to do centralized visualization. And when I had this, I ended up thinking, well, I do have visualization, but I still need to copy and paste every single payload around and still SSH to the honeypots to find something. So I started automated collection and storage in the platform, which is MISP. And finally, I thought about I can even enrich based on MISP and with MISP. So unfortunately, because of the time frame, we will just focus on the visualization part and the deployment and collection of data. But again, if you're interested in more, just hit me up. I will gladly tell you more about this. So how do you collect data? Basically, you can start with, spare hardware that you've got lying around, and even use VPSs. So the possibilities are endless. So I started with a single used Raspberry Pi 1B. So there is basically no excuse in not doing this. What I would recommend you to do is scenario 1, if you do this for an internal honeypot deployment, as in maybe a preemptive system that shouldn't be known by anyone, then please do not expose this honeypot to the internet, because you need to put it near your production servers. And having something vulnerable in the same network as your production servers isn't something that you should do, at least not with public access. So if you want to have public access on your honeypot, please do this by putting the honeypot into a DMZ, or at least having it separated in a different network than your production environment. So you should treat your honeypot as a throwaway system, so please do not use production data. So no reuse of usernames, passwords, or SSH keys, and please try to avoid root. I will tell you a little story about that later on. So what's important is you're exposing code to the world that looks vulnerable, but it most likely is vulnerable, but in other ways than you'd think. So the attacker has the advantage here. So they have infinite time and ways to try things. You, on the other hand, need to mess up once for them being able to possibly own the system and everything in the same network. Which brings me to the next point of detection and evasion. So what's happening outside is that people constantly try to detect and evade honeypots because they don't want their payloads analyzed by researchers, as you would think. So one of the easiest things that you can do is evaluating host names, service versions, and trying default usernames and passwords. So that's something, if you get a honeypot and you set it up, please try to change as many default settings as you can. Because, for example, what you can see here is that Cowrie per default used to have the hostname SVR04, which led to automated attacks trying to, or parsing the host name and then disconnecting if they found that the system had this host name. Another common thing that that authors try to evade honeypots is using a shell script or a multi-stage payload to try and make use of one of the main principles of low and medium interaction honeypots. Especially these two tend to disown payloads as soon as and files as soon as they are written to disk, so that they cannot be executed. Which means if you upload a bash script to a honeypot and try to execute this afterwards, it won't be there, it won't work, and therefore you successfully evaded the honeypot. What you can do against this is basically only the use of high interaction honeypots that emulate a full system. But the whole thing is a cat and mouse game, and if you're interested in a little bit more of detail about this, I can happily recommend you the talk Breaking Honeypots for Fun and Profit, which is a very interesting talk that goes a little bit more into detail on which honeypots can be detected in which way. So they present some common and interesting ways how they were able to find honeypots. And as I mentioned before, the most important thing is try to customize your honeypot. So most attacks out there are automated, which means there is no human that looks at every single thing or every single connection their scripts do. So if you want to evade this, if you want to try and keep them on your pot, try to change as much defaults as you can, and also make your service look real. So that's another thing. If you think about MongoDB cluster, it is unlikely that a big MongoDB cluster deployment of 5 or 6 machines, that every single machine of them has only 256 MBs of RAM. So try to make it look real, try to have reasonable sizing. You don't have to have it in hardware, but make the honeypot show reasonable sizing, which is something that it can do usually. And also think about cluster state. That's something that especially bigger deployments are quite good at in emulating. So you've got all your honeypots up and running now, but they look like this. So all you can see is text scrolling down your screen, which is something that is not nice to read for humans. So what can you do? What can I recommend you to do is use something like Splunk or Elastic to sift through this haystack of semi-structured log data and visualize it. How can this look in reality, just as a quick glance? As you can see here, this is my live Splunk deployment. And as you can see, this is kind of an overview of the main, this is the main dashboard that then branches out into details on how each honeypot performs. So if we take an IoT honeypot that we've developed ourselves, you can see that we've got quite a bit of insight in how this honeypot is used, how it got hit, and what people do on it. So basically, this visualization is something that heavily depends on your use case. So it is always recommended best practice to define your use case and especially define what you want to see or visualize beforehand, and then building dashboards and visualizations for this. And there is something that you should keep in mind when you build dashboards, which is filtering noise. What you see here is something, these are payloads that got uploaded. And if you have a look at the SHA hashes, you can see that every payload has a different hash. But all of them share a common file name or upload path. And this is where you can see that these files don't hold any valuable information. They are just generated noise. And this is something you should always be on the lookout for, especially as it pollutes your visualization and your dashboards. But enough from the technicalities. Let's have some fun and look at the fun stuff, which is also known as everybody fails from time to time. So what this is common pitfalls that I encountered in running honeypots and common pitfalls that users of my honeypots encountered. So what happens to me more often than I would like to admit is I connect to my honeypots or want to connect to my honeypots for some quick maintenance. And I'm wondering why my SSH key isn't working. I mean, I'm sure it's the right password. So think about it. What could happen? And yes, so this usually ends up me being just really connecting to the honeypot itself and not on the host system. So I reset all my passwords, keys, scrub all of my data out of my Splunk dashboards, and basically do a cleanup on AL5, unfortunately. So all infrastructure was up and running at one point. So I had multiple VPS providers running my honeypots, and I had all my infrastructure spread around the world. The problem was there was quite a big debt pooling scam going on, and mind you, this is my private money this is my private project. So I chose the least expensive providers that I could find, which all basically closed down without further notice. So all my honeypot infrastructure was gone. In the process of having my infrastructure, I decided to move Splunk to another host. So Splunk at this point holds all of my data and all of my payloads and executed commands. And I forgot to check backups, which means, I tried to move it. I decided on just deleting it on the one provider and then using my backup to restore it on another one. And yeah. Basically, I'm not the only one that this happened to. So please check your backups, check that backups are done, and verify your backups. It's a heartfelt thing that you should think of. So what I also did, and what I wouldn't recommend, is deploying honeypots to system Python. So I would recommend, at least if you're running Python honeypots, use a virtual env, because the next apt update will definitely update some Python dependency, and this will break all of your honeypots. At least this is what happened to me. What I also did was I updated the list of allowed passwords on one of my honeypots. And I started seeing lots of denied password attempts. And yeah, I ended up pasting the wrong format for the file, which allowed my honeypot no more logins at all. And that's something, I haven't seen because I wasn't monitoring my honeypot. So maybe either have this done by configuration management as an Ansible, or maybe monitor your honeypots, which is also a thing that I would recommend. And finally, there it is again. Please do not run your honeypots as root. I did this. The system got owned quicker than I would like to admit. And yeah, I ended up rebuilding the whole system. Please don't make the same mistake I did. So basically, best practices, please monitor your honeypots, especially storage and services, as in, are they running correctly? Are they storing? Is there enough storage? Is there enough room? And regularly clean your payloads and logs, because what happens is you can have the best honeypot infrastructure. If the device is full, it's full. So what have I found as well? I have found something, or I can give some best practices maybe for aspiring developers, which is maybe do something after you connect. So this is something from my SMTP honeypot. And as you can see, this is the connection count per minute. So there is a barely noticeable spike with 250 connections from a single IP in 2 minutes. I mean, maybe my honeypot is broken, but it feels a little bit like this. So Another option is please provide actual login data if you try to log into one of my systems, because if you're using the port and the IP, that is definitely something that shouldn't be in username and password, or system commands shouldn't be username password, or your ini file title for login shouldn't be there. And finally, always check your strings. So in this case, the avid reader might have seen it as in this is an invalid address, so there's no IP address. And there's something also interesting for me, because this is something that happened on my ADB honeypot more often than on any other honeypot. Attackers just dumped all their payloads in a Hail Mary attack and tried to execute them, which means I get to have all your fancy honeypot, all your fancy payloads on my honeypot. And finally, there's some just weird things that I found over the time. So, for example, these are user agents on my honeypot, on my IoT honeypot, and keep in mind these are easily forgeable, but there's something interesting, as in there are some messages from well-known agents and well-known services. And then there's this. I still don't know how this got there. And there's always this one special friend you have that runs his own ASN. Which is also an interesting thing to see on your honeypot infrastructure. And finally, having a look at things that get uploaded is something that is definitely always worth a shot. For example, this is an SSH key, or public part of an SSH key, and if you find this in your infrastructure, you should maybe start thinking about if you're getting breached or not, because this is an ongoing distribution of an SSH key, and this key, I started seeing it roughly in December last year, and to this date I have catched it from more than 1,100 different source IPs. So if you find this in your infrastructure, maybe think about nuking most of your infrastructure. So, conclusion. The next things for me are high interaction honeypots or nested virtualization, which is a thing that is quite complex, but is getting more and more usable by day. And in general, I would like to do more tooling integration and more automation, as in I'm not good at reverse engineering, so I'm leaning on my strong suits in automation and building workflows that do stuff automatically without me interfering with it. I want to give you, on the other hand, the chance to use the things that we've built and profit from the research we did, which is I can recommend you the honeypots that we've built and the Splunk dashboard that I have shown you in this presentation. You can download these and use them with little tuning in your own infrastructure. And there's generally a list of highly recommended resources and projects that you should check out should you be interested. So, in conclusion, I want you to deploy honeypots. Deploy them today. It's low cost, it is virtually no maintenance, and gives you high value. So, what's holding you back? So, you've made it. Thank you for your attention. That's it from my side, which means if there are any questions from your side, please go ahead and contact me, for example, via Twitter, or write me a mail. I'm happy to discuss and share my knowledge with you. Thank you.